Section 3.4 is solving quadratic inequalities. There's a couple of different ways that we're going to look at solving quadratic inequalities. The first way that we're going to look at solving them is graphically. So a quadratic inequality takes that quadratic equation, here's the quadratic equation, and it replaces the equal sign with an inequality, either a greater than or equal to, less than or equal to. Your solution then will be an interval, a range of values of x that will make the inequality true. Your first step will always be to find where the quadratic equation is equal to 0. This is how we get our boundary numbers. The boundary numbers are just your x-intercepts. So when you're solving a quadratic inequality graphically, your first step is to rewrite the inequality in standard form, where you have the ax squared plus bx plus c either greater than, less than, greater than or equal to, or less than or equal to 0. Then you want to graph the quadratic equation. You can do this on your graphing calculators, or you can do it by hand, and then determine your x-intercepts. Your x-intercepts may have to be found either using the quadratic formula or factoring, because they don't cross at an exact whole number on the x-axis. So keep in mind, you may have to use techniques from 3.2 to find these numbers. Depending on the inequality symbol, you want to locate the x values where the graph is either going to be above or below the x-axis. If you have greater than 0 or greater than or equal to 0, you want to know where the graph is above the x-axis. If you have less than or equal to 0, that's where your graph is going to be below the x-axis. And then we'll use that information to solve the quadratic inequality. In example 1, we're asked to solve the quadratic inequalities graphically. So for part A, the first thing I'm going to do is get a graph. And what I graph is 1 minus x squared. And I'm going to change my window to get a better picture. So here's the graph of y equals 1 minus x squared. On this one, it's easy to see that our x-intercepts are going to be at this point, -1 and +1. On part A, we're asked to find where is this quadratic expression or this quadratic inequality going to be less than 0. Less than 0 means negative. Negative means you want to know where is your graph below the x-axis. So that's going to be from this interval to the left and this interval to the right, because that's where my graph is below the x-axis. Does that make sense? The way that we would express this answer for part A is it would be the interval that goes from -infinity to -1 union 1 to infinity. For part B, I want to know where is this quadratic expression greater than 0. Greater than 0 means where is it above the x-axis. So that's going to be here in between -1 and 1. And the way that I express this interval using interval notation is it's the interval that goes from -1 to 1 using interval notation. How would I express this if I was asked to write this answer using an inequality? This is writing your answer as an inequality. This is the same answer using interval notation. How would I express part A as an inequality? X is less than -1 or x is greater than 1. So this is the answer expressed as an inequality. This is the answer expressed in interval notation. But do you see how we get both answers just from looking at the graph? Example 2, we want to solve this inequality graphically. The first thing I need to do is rewrite this so that I have a 0 on one side and the quadratic expression on the other. I always personally like to have my leading coefficient positive. So what I'm going to do here is subtract 5 and add 4x to both sides. So I'm going to rewrite this inequality as x squared plus 4x minus 5 is, now the 0 is going to be over here, so that's going to be greater than 0, because the big end of this was opening towards the x, it still has to be opening towards the x. Since we're solving this graphically, I'm going to go ahead and graph this quadratic expression, and that's going to give me x squared plus 4x minus 5, and then I'm going to hit graph. Anytime you hit zoom 6, it'll give you a standard window, so this is good enough. We'll take this as our answer for our graph. The first thing you need to do is identify where your x-intercepts are. This factors, doesn't it? This would be x plus 5 times x minus 1. So where are my x-intercepts going to be? -5 and 1. This point right here is at -5. This point right here is at 1. Now I wanted to know, where is this greater than 0? So do I want in between, or do I want at the endpoints? Greater than 0 means above the x-axis, and that's going to be these endpoints right here. So my solution is what I have shaded in red right here, and the way I would write that using interval notation is it would be the interval that goes from -infinity to -5 union 1 to infinity. If I asked you to write it using an inequality, you would say x is less than -5 or x is greater than 1. What would have to change so that I would put brackets here instead of parentheses? It has to be greater than or equal to. I haven't come across an example like that. I just wanted to make sure you remembered that. Now, another way that we can solve quadratic inequalities is not by graphing, but actually using our brains and pencil and paper, solving inequalities symbolically. Step 1 is the same. You still want to have your quadratic expression on one side with a 0 on the other side. Then you want to solve your quadratic equation to get your boundary numbers. We call these critical values. Right here where I had this factored, -5 and 1 were my critical values, these boundary numbers that separated where the graph is either above or below the x-axis. Step 3 is to use the boundary numbers to separate the number line into open intervals. Note that on each open interval, that graph is either going to be positive or negative. Looking at the problem that we had up here, my x-intercepts divided the graph into 3 different intervals where the graph is either always above the x-axis, below the x-axis, or above the x-axis. And then step 4 is you want to choose a convenient test point from each of those intervals and then evaluate the sign of the quadratic expression at the test point. It's either going to be positive or negative. And then depending on your inequality, whether it's greater than or less than, you'll write your answer that way. So in example 3, we're asked to solve this quadratic inequality symbolically. Our first step is to make this quadratic expression all on one side and a 0 on the other. So I'm going to subtract a 2 from both sides and add an x. And when I do that, that gives me x squared plus x minus 2 is greater than or equal to 0. Now I've got to find my x-intercepts. Fortunately, this one factors, so these are fairly easy to find. This is going to be x plus 2 times x minus 1. So my critical points, or cut points, are going to be where this quadratic expression is equal to 0. So that's going to be at -2 and at 1. Those would be my x-intercepts. So I use those numbers to divide the number line into intervals. So -2 and 1. Because this is a number line, we have order associated with the number line. So the smaller numbers need to go on the left, the larger numbers on the right. This first interval goes from -infinity to -2. Then we have the interval from -2 to 1 and from 1 to infinity. Your next step is to pick a test point in each interval in order to check the sign of this expression in that interval. So I'm going to test, and it can be any number in this interval. X equals negative, give me a number. -3 is in that interval. -1 is not. Be careful. Go to the next interval. What do you want to test? If 0 is available, the arithmetic with 0 is easy. Use it. And then we go to the next interval. What do you want to test? 1,000? 1,000 works. Why not? We could test 1,000,000. It still works. Now here's where this gets interesting. The reason I like this factored is because I'm only checking to see if my function is positive or negative in the interval. I don't care what the numbers are. I just want to know the sign. So I'm going to plug in a -3 into each of these factors. -3 plus 2 is negative, and -3 minus 1 is negative, and a negative times a negative is, go to the next interval and we plug in a 0. 0 plus 2 is positive, 0 minus 1 is negative, and a positive times a negative is negative. Go to the next interval. 1,000 plus 2 is positive, 1,000 minus 1 is positive, so the whole interval is positive. Now you look at the sign, or at the inequality. Greater than 0 means positive. So your answer here is going to be the 2 intervals that gave you positive values. So that means that our answer here is going to be the interval that goes from -infinity to -2. Do I put a parenthesis or a bracket? Bracket, union, 1 to infinity. Now we can verify this using the graph if you want. Our x-intercepts are going to be at -2 and 1. This is a quadratic that's going to open up. So if I were to sketch the graph, just kind of rough it in. When we graph this, our vertex is going to be somewhere down here. It's going to open up, and our positive intervals are where the graph is above the x-axis. That's less than -2 but greater than 1. One last example. When I rewrite this quadratic expression, I'm going to get x squared plus 2x minus 15 is less than or equal to 0. Will this factor? Plus 5 and minus 3. So I have critical points or cut points at x equals -5 and x equals 3. Those are the numbers that I use to divide my number line into intervals. So I have -5 and 3. This first interval goes from -infinity to -5, then from -5 to 3, and 3 to infinity. Then I've got to pick test points in each of the intervals. What number do you want to test in that first interval? -10 works. What about in the next interval? If 0 is available, use it. And then in the next interval, you want 10. I'm picking 4. Then what do I do with my test points? Once I have this already, plug them in where? Into the factors. So -10 plus 5 is negative. -10 minus 3 is negative. And a negative times a negative is positive. Then we test 0. 0 plus 5 is positive. 0 minus 3 is negative. I'm going right here and replacing x with 0. And a positive times negative is negative. Then I'm going to plug in a 4. 4 plus 5 is positive. 4 minus 3 is positive. Positive times positive is positive. I'm only interested in the sign, not what the numbers are. Yes, sir. You get 0. That's why you never use these numbers as your test points, because they're the boundary points. That's where this is equal to 0. It wouldn't be that. It would have a minus 2x there instead of a plus 2x. You have to factor it correctly in order for it to work. Because this is less than or equal to 0, which one of these do I want for my answer, the positives or the negative? Less than or equal to 0 means negative. Negative numbers are smaller than 0. So my answer would be the interval that goes from -5 to 3, but I don't want to put a parenthesis there. I want a bracket. Or you could write x is in between -5 and 3. That would be your answer written as an inequality. And this wraps up section 3.4.